Welcome to Lesson 9, where we cross the line from writing classes that work to writing classes that feel native. Dunder methods, those double underscore hooks like OrderID, and OrderID, are how Python lets your objects plug into the language itself. Define I-repr, I-core, and suddenly print gives you something useful. Define I-core, and double equals just works. By the end, your custom types behave like built-ins, and that distinction quietly disappears. Here's the roadmap. We'll work through 4 categories of Dunder methods in order of how often you'll reach for them. First, repr versus the gateway habit, one for developers, one for users. Then, paired with hash. Because value equality and hashability always travel together. After that, the container protocol, L10, and contains, to make your class loop and look up like a list. And finally, operator overloading with and used sparingly, only when the math is genuinely natural. So let's start with the gateway habit. Without as-repr, printing your object gives you that useless angle bracket memory address. Fine for the interpreter, terrible for you at 2 in the morning chasing a bug. Add a repr that returns something like username Laszlo, and suddenly your logs, your tracebacks, your REPL sessions, even lists of objects all become readable. One small note on the F string. The byte flag calls repr recursively on the name, so strings get their quotes preserved, which is exactly what you want for a faithful representation. From readability, we move to equality. By default, 2 money objects holding €100 are not equal. Python compares identity, the memory address, not the contents. Define and now you're comparing what actually matters, amount and currency. Return not implemented for foreign types, so Python can try the reflected operation. And the moment you define you owe a matching HU hash, ADDs, same fields in, same hash out. Otherwise, your money silently breaks inside sets and dict keys. Now we cross into containers. 3 small dunders turn a plain cart into something that behaves like a list. My makes for item in cart work, my powers len cart, and contains handles item in cart. Notice we just delegate to the underlying list, iter of self, items, len of self, items, item in self, items. The caller writes idiomatic Python and never has to know cart isn't built in. That's the whole point. Dunders dissolve the seam between your classes and the language itself. And the same trick extends to operators. Define add, and the plus sign just works on your objects. Mule, wires up multiplication, LTR gives you less than and sorting for free. Money plus money returns a new money, with a currency check baked in, and money times an integer scales the amount. One caveat, though, only reach for this when the arithmetic is genuinely meaningful. Money, vector, decimal, yes. A user or an order, almost never. Let's see all of this come together in one realistic class. OrderID is just a typed wrapper around a string, but with 6 dunders, it stops feeling like a custom class at all. Repr for debugging, str for user-facing output, EQ plus hash so it works in sets and dict keys, and so sorted just works. The validation in init gives you type safety the raw string never had, and everything downstream behaves like it's built into the language. So let's distill all of this into 6 reflexes you can carry into every class you write. Always add repr it. It's the highest ROI dunder, 2 lines that save you hours in logs and the REPL. Define EQ and hash e as a pair. Never one without the other. In comparison and equality methods, return not implemented for unknown types so Python can try the other side. Don't raise type error. Reach for total ordering when you need sorting, only overload operators when the math is genuinely obvious. Money plus money, yes. User plus user, no. And remember, a data class gives you most of these for free, which is exactly where Lesson 10 picks up. And here's the whole lesson on one page. 12 dunders worth pinning above your monitor. The top row is identity. How your object gets built, how it looks to you, how it looks to users. The middle rows are behavior, equality and hashing together, ordering for sort, and the container protocol that makes len for and in just work. The bottom row is the power tools, operator overloading when it's obvious, and the two decorators that hand you most of this for free. Now, 5 traps I see constantly in code review. First, defining identity without hash silently makes your object unhashable. Sets and dict keys just stop working. Second, a repar that reads like prose belongs in *. Repar should look like the constructor call. Third, when types don't match in eq return not implemented, never raise. Python needs that to try the other side. Fourth, only overload operators when the math is genuinely obvious, like money or vector. And fifth, if your hash depends on mutable state, lookups will break the moment that state changes, make hashable objects immutable, or let frozen data classes do it for you. Time to put this into your fingers with 3 exercises. First, build the OrderID class. In it with validation, repar, str, eq, hash, and lt for sorting. Then prove it works as a dict key and inside a set. Second, take the cart from Lesson 2 and make it container-like with iter, len, and contains. So, for item in cart, just works. And third, the capstone. Implement money with eq, hash, and total ordering, raising value error on cross-currency addition. Finish these and the advanced section is done. Professional is next, where data classes give you most of these dunders for free. And that's the advanced tier in the books: repar, eq and hash, iter and len, and operator overloading. Your classes now behave like first-class citizens in Python. They print cleanly, compare correctly, iterate naturally, and respond to operators. Next up, Lesson 10 shifts the tag to Professional, where data classes erase most of the boilerplate you just learned to write by hand, and protocols bring static typing to duck typing. See you there.